Hi guys, today we're going to do some more practice with the three factoring methods that we've looked at so far. So that would be AC method, difference of squares, and grouping. So we've got some practice problems here. For each of these functions, we're going to change it to factored form, and then we're also going to state our x and y intercepts. So problem number one, we've got three terms. Remember, anytime I have three terms, I want to look at AC method for factoring. Okay, so I'm going to use AC method here for this first problem. So for AC method, remember that's where I start by identifying my leading coefficient and my constant term, and I'm going to multiply those two together. So 2 times -3 would give me -6. And now I want factors of -6 that add to the coefficient of my middle term. So that would be, in this case, -1. If you have trouble identifying those factors right away, remember you can make a list. So 1 times -6, -1 times 6, 2 times -3, or -2 times 3. Those are all of our factors of -6. I want the ones that if I added them instead of multiplying, I would get -1. So I want 2 and -3. So now I'm going to use those factors to actually split up this middle term into two terms. So I'll have 2x squared plus 2x minus 3x minus 3. Notice that my first term and my last term have stayed the same. It's the middle term that I've rewritten. If I were to combine my like terms here, we would get back to -1x. Now that I've rewritten my problem in four terms, we could use our four-term strategy. Our four-term strategy is grouping. So I'm going to split this group of four terms up into two groups. So the first two terms and the last two terms. And then I'm going to look for the GCF for each of these groups. So in my first group, my GCF, my greatest common factor to both of these two pieces, 2x squared plus 2x, my GCF here would be 2, since they both have a coefficient of 2, that means it's common. And then they each have an x. So I'm going to pull out an x. So I'm going to factor 2x out here. And then in parentheses, I'm going to write what's left over when I factor that out of this first group. So 2x squared divided by 2x would leave me just x. And then 2x divided by 2x would be 1, the same as 2 divided by 2 is 1. And then I do the same thing for my second group. -3x minus 3, I've got -3 in both of these terms, so I'm going to factor that out as my GCF. Left over, I would have x. -3x divided by -3 would give me just x. And then -3 divided by -3 would be 1. Remember when we're using that grouping strategy, the stuff in parentheses, after you've taken out your GCFs, that stuff should be the same. If it's not the same, you need to go back and double check your work, okay? Since I have this stuff the same here, that acts as my new common factor, right? It's common to both of these terms. So I'm going to factor it out. And then just like I did before, I'm going to write what's left over. So I like to actually just cover that up with my fingers so I can see those leftover pieces. So I would have 2x and -3. So 2x minus 3. At this point, I have no more x squared. I factored this as much as I can. So this is my factored form. X plus 1 times 2x minus 3. That's my factored form. And now we're going to identify our intercepts. The y-intercept is the easy one because I can see that from standard form. Remember that constant term at the end is your y-intercept, okay? That number at the end of your standard form with no x. So our y-intercept is -3. And then our x-intercepts come from our factors here. So x plus 1 means I would have an x-intercept at -1. And then the trickier one here is this 2x minus 3. Since I have a number in front of the x here, I'm actually going to go ahead and set that equal to 0 and get x by itself. So I'm going to add 3 to both sides to start. So I have 2x equals 3. And then to get x by itself, I'm going to divide both sides by 2. So I would get x to be 3 over 2, or 1.5. So that's my other x-intercept, 3 over 2. Okay. So that was a 3-term problem. We used AC method to factor and found our x and y intercepts. Now we're going to try our second problem. Here we've only got 2 terms. When I have 2 terms, and I've got an even degree subtraction, I'm going to use that difference of squares strategy. Okay, difference of squares here. So I'm going to start by looking to see if there's already a GCF for each of these terms. I've got 9x squared minus 25, no common factors there. So I'm going to jump straight into figuring out what did I square to get each of these terms. So for 9x squared, to get 9, that means I had to square 3. And to get x squared, that means I had to square x. Then we'll look at our second term here, 25. To get 25, I would have to square 5. Once I figured out what I squared to get each of these terms, writing my factors is actually pretty simple. Remember that first term goes at the front, the second term goes at the back. So I'm going to set that up for each of my factors, and then just opposite signs in between. So 3x plus 5 and 3x minus 5. Okay, always the first term in the front, always the second term in the back of each factor, and again, those opposite signs. So our factored form here is 3x plus 5 and 3x minus 5. Our y-intercept comes from the same place it did in that last problem. Since we have standard form, it's going to be that constant term at the end. So my y-intercept is negative 25. And then for our x-intercepts, since I've got numbers in front of my x's in these factors, I'm going to go ahead and set each of them equal to 0 so I can solve for x. Okay? So for 3x plus 5, I'm going to subtract 5 to start. So I get 3x equals negative 5, and then divide both sides by 3. So I get x equals negative 5 over 3. So there's one x-intercept, negative 5 over 3. And for the other one, 3x minus 5 equals 0. This time I'm going to start by adding 5 to both sides. So I get 3x equals 5, and then divide both sides by 3. So I get x to be 5 over 3, 5/3 there. Okay? So y-intercept, factored form, and my x-intercepts. The next problem that we're going to take a look at is already written in 4 terms. So that means I'm going to use my 4-term strategy, which is grouping. Okay? So I'm going to take this thing that's 4 terms and split it up into groups of 2. Now, remember, anytime I start factoring, I always want to look for a GCF to start. Is there any factor that's common to all of these terms? In this case, no. So I'm going to go straight to grouping. And then again, I'm looking for the GCF, the greatest common factor for each of these groups. So for 4x squared and 2x, 4 and 2 are both divisible by 2, and x squared and x are both divisible by x. So 2x will be my GCF here. So now I'm going to factor this out or divide this out of each of these terms. So 4x squared divided by 2x would give me 2x. And then 2x divided by 2x, the same as 2 divided by 2, we talked about this already, that would be 1. For my second group here, 18x plus 9. 18 and 9 have a common factor of 9, so I'm going to factor out 9. 18x divided by 9 would leave me with 2x, and 9 divided by 9 leaves me with 1. My stuff in parentheses is the same. Remember, I always want to see this stuff be the same when I'm using grouping. So now I'm going to pull that out as my GCF, right, since it's common to both of those terms. And left over, when I factor that out, I've got 2x plus 9. 2x plus 9. Okay. I've got plain old x's here. I factored as much as I can. So my factored form is 2x plus 1 times 2x plus 9. And now let's identify those intercepts. Again, that constant term at the end, the thing with no x, is my y-intercept. So my y-intercept is 9. And then again, since I've got numbers in front of x in my factors, I'm going to go ahead and set those equal to 0 so that I can solve for my x-intercepts. So for 2x plus 1, I'm going to start by subtracting 1 from both sides. I get 2x equal to negative 1. Then I'm going to divide both sides by 2, and I get x to be negative 1/2. So there's my first x-intercept, negative 1/2. For 2x plus 9, I'm going to start by subtracting 9 from both sides. So I have 2x equals negative 9, and then divide both sides by 2. So I get x to be negative 9/2. And you can just leave that as an improper fraction. That's fine. There are my x-intercepts. Number 4, same idea. I've got 3 terms this time, so that's going to tell me that I want to use probably my AC method. Again, we want to start by looking to see if there's a GCF already. And for this problem, 7x cubed plus 14x squared plus 7x, I actually do have a GCF, a greatest common factor, to take out right at the beginning. So each of my coefficients are divisible by 7, and then each of my terms has an x, so I can also take out an x. So 7x is my GCF here. Okay? When I factor this out, I would be left with x squared plus 2x plus 1. Okay? Again, I've divided each term by 7x. Now I'm going to continue to factor this stuff in parentheses, x squared plus 2x plus 1. Since I've got 3 terms here, I'm going to use AC method, so I need to identify my lead coefficient and my constant term. I don't see a number in front of x squared here. That means that it's 1. So I'm going to take 1 times 1. That gives me 1. And now I want factors of 1 that add to 2. Well, that would be 1 and 1. So I'm going to rewrite this part here, this trinomial, this 3-term piece, by splitting up the 2x into 1x plus 1x. So I would have x squared plus 1x plus 1x plus 1. A lot of 1's in there. Okay? And then don't forget, we still have that 7x just hanging out in front. Now that I've rewritten this in 4 terms, I'm going to use grouping. And I'm going to look for the GCF for each group. For my first group, my GCF would be x, since it's present in both terms. When I factor that out, I would be left with x plus 1. For my second group, I don't have an interesting GCF, but I have to pull something out when I use grouping. So I'm just going to pull out a positive 1. And that would leave me with x plus 1. Now my stuff in parentheses is the same. So that acts like my new GCF. And then my other factor is the stuff that's left over. So x plus 1. And then don't forget that we still had our 7x hanging out in front here. That GCF that we pulled out at the start. I have no more x squareds, so this is my factored form. 7x times x plus 1. And then since I have the same factor twice, I can actually write that as x plus 1 squared. My y-intercept on this one is a little tricky. If I look at the end of my function, that term has an x on it still, but we need our constant term for the y-intercept. Since I don't see it, that means it must be 0. So our y-intercept on this one is 0. And then for our x-intercepts, I'm going to take each factor that has an x and set it equal to 0. So I had a GCF with x that we pulled out at the start. So I'm going to take 7x and set it equal to 0. And then x plus 1 equal to 0. I know we had an x plus 1 factor earlier, and we just pulled the x-intercept out of that. I'm going to go ahead and set this one equal to 0. And then this would be the same thing. Since I have that second factor of x plus 1, you don't actually need to solve both of these. It's just going to repeat the same x-intercept. Here, for our 7x equals 0, I would divide both of these by 7, and we would get an x-intercept of 0 there. And then for our x plus 1, I'm going to move that 1 to the other side, and I get negative 1 for our other x-intercept. You could solve on this one too, but you're going to get the same thing. Since it's the same x-intercept, right now you don't need to list it twice. Okay? That would be our factored form on number 4. Just a couple more problems that we're going to take a look at. Number 5, another 3-term problem. So we're going to use AC method again here. My A value, since I don't see it, is a 1, and my C is 16. So 1 times 16, that gives me 16. I want factors of 16 that add to 8. Okay? If you need to, make a list. Start with 1 and go in order. 1 times what, 2 times what. But I see here that we're going to need 4 and 4. 4 times 4 gives me 16. If I added them instead, I would get 8. So I'm going to rewrite this as x squared plus 4x plus 4x plus 16. And now, since it's 4 terms, I'm going to use grouping. So I'm going to split this up into groups of 2 and then look for my GCF out of each group. For my first group, x squared plus 4x, I've got x in both terms, so that's my GCF. When I factor that out, I'm left with x plus 4. X squared divided by x leaves me with x. 4x divided by x leaves me with 4. And then for my second group, 4x plus 16. 4 and 16 are both divisible by 4, so I'm going to factor out a positive 4. 4x divided by 4 would give me x. 16 divided by 4 would give me 4. Again, I want my stuff in parentheses to be the same. Since it is, I know I've done my work correctly. So I'm going to factor that out. And then left over, I would have x plus 4. We have the same factor twice again here. You can write this as x plus 4 times x plus 4. Or I can shorten it to x plus 4 squared. That's also fine. Our y-intercept would be that constant term at the end, 16. And then our x-intercepts, it's just going to be the same thing both times. I would get negative 4 as my x-intercept here. Okay. If you can identify that from the factor, great. We don't have a number in front of x on this, so it's just going to be the opposite sign of whatever I see here. If you would rather set that equal to 0 and then get x by itself, that will always be a good strategy to use. The last problem we're going to take a look at here, number 6, we've got 4 terms again. So I want to use grouping. And I've not stated this for the last couple of problems. But again, we always want to make sure I start by scanning my problem for a GCF. Do I have a greatest common factor for each of these terms? In the case of number 6, no. For number 5, also no. Okay, so I'm going to go straight to grouping here. My GCF for the first group would be each of these terms have an x. I'm going to pull out an x. And then remember, we can actually pull out whatever that smallest exponent of x happens to be. So in this case, that's x squared. So I'm going to pull an x squared out here. And then left over, I have x minus 2. For our second group, I've got negative 4x plus 8. Anytime your group starts with a negative, that's a pretty good indicator that you're going to want to pull a negative number out as your GCF. So 4 and 8 would have a common factor of 4, but I'm going to pull out negative 4. Okay? That's going to help with my signs for the second part. So negative 4x divided by negative 4 would be positive x. Remember, I want my stuff in parentheses to match, so I need this x to be positive. And then 8 divided by negative 4 would give me negative 2, which again gets those signs to match. If you had just pulled out 4, your signs would be opposite here, and that would be a problem. Okay? Since my stuff in parentheses is the same, I get to pull that out as my GCF. And then left over, I have x squared minus 4. Now for this particular problem, I have finished factoring by grouping, but I see one of my factors here still has an x squared, okay? I've got something that's 2 terms with an even degree, subtraction. This thing now I can factor as a difference of squares, okay? So I get to keep factoring on this one. So that means I need to identify what did I square to get each of these pieces. So to get x squared, we would have to square x. To get 4, we would have to square 2. So this x squared minus 4 factors into x plus 2 times x minus 2. So my full factored form would be x minus 2 times x plus 2 times x minus 2. So I'm just going to write that out exactly as I had it written already. Since I've got 2 factors of x minus 2, you could also write this as x plus 2 squared, x plus 2 times x minus 2 squared. So I've got 2 x minus 2s. This would also be fine. I'm just going to write it as we had it in our problem. And then we want to identify our intercepts. So that constant term at the end is our y-intercept. So our y-intercept is 8. And then our x-intercepts come from our factors. So from this x minus 2, I would get a positive 2. From x plus 2, I would get a negative 2. And then from here, this other factor of x minus 2, I would get another positive 2. Since it's already in my list, I don't need to write it again. Okay, so that's a quick review of those 3 factoring strategies that we've looked at, AC method, grouping, and difference of squares.